Object tracking is the process of locating a moving object in a video. You can consider an example of a football match. You have a live feed of the match going on, and your task is to track the position of the ball at every moment. The task seems simple for an average human, but it's way too complex for even the smartest machine. As you may know, computers only understand numbers. It doesn't understand what an image is, but the pixel values associated with the image. Two images appearing to be exactly the same to the human eye may not be the same case for your computer, as even a slight change in a pixel will result in a difference. Because of that, object tracking is considered one of the most complex tasks in computer vision. Although complex, it's not something unachievable. This is the video I am using for object detection. Let me play it. First of all, we will import the required libraries that we'll be using. We will be defining a function that will resize the images so that we will fit on our screen in case they are big enough. The step is completely optional and feel free to skip it. As you might know, videos are made of frames. Frames are nothing but one of many still images that together make up the whole moving picture. The next step will be reading those frames using the video capture function in OpenCV, and using the while loop we can see the frames moving. You can adjust the speed of the video using cv2.wait key, which pauses the screen for milliseconds. Now it's time to perform some thresholding and pre-processing. OpenCV reads images in BGR format. So we will be converting the colors from BGR to HSV. Why HSV and not BGR or any other format? We are using the HSV color format because it is more sensitive to minor changes in external lighting. Hence, it will give more accurate masks and hence better results. After converting the color space, that we have to do is to filter out the red channel and create a mask frame. Red channel in HSV format is present in 0, 230, 172, 255, 255, 220 range. Till now, we have created the masked image of the frame and we have filtered out most of the noise. What next is to get the boundaries of the ball. To do that, we will be using the concept of contour detection. Contours are nothing but boundaries that will surround our ball. Thankfully, we don't have to find those boundaries in our own, as OpenCV allows a function find contours which can be used for our purpose. It takes a masked image and returns an array of contours. In ideally, in our case, the value of contours should be 1 as we have one ball only. But due to some people who were wearing red hats, we will get more than once. Can you think of something further reduce this noise? To handle this problem, we will be going to use another function from OpenCV, that is cv2.contourArea. We know in the mask image, the ball has the largest area and so will its contour. Hence, we will get the contour with the largest area. We have the contours of the ball and we can directly draw these contours using cv2.drawContours function. For, but for detection tasks that we generally do is to use a tightly bound rectangle to show that the object has been detected. To do so, we will be using cv2.boundingRect function. This function will return the coordinates of the rectangle and then cv2.rectangle function will draw the rectangle for us. Moreover, what we can do is to detect the centroid of the ball simultaneously. For that, we will be using cv2.moments. cv2.moments calculates the weighted average sum of pixel intensities within the contour and hence allows to get more useful information from the block, like its radius, centroid, etc. Make sure to convert the image to binary format before using the function. So in this video, we have used object detection in each frame for the task of object tracking. Though useful, it might not work well in every case. While reading this input videos, uh, several questions might have hit your brain